Okay, these things we have been discussed in the previous class. These are actually the Laplace transform. To understand the Laplace transform, you need to understand the equations, some equations, the table. Let me show you the table again. These things, Laplace transform table, impulse response 1, state response 1 by s. This is ramp 1 by s square t to the power n ut e minus at ut. This is the time domain function, and if you convert it to the frequency domain, then you will find this. That means time domain to frequency domain, Laplace transform. Inverse Laplace transform means from the frequency domain to the time domain, the opposite one. Okay, and this kind of equations will come. Okay, just a minute. Okay. Transfer function. We have started this one in the last class. The transfer function is actually what? Let me show you again. Let's say uh, that is your input, and that is your output. Here is the transfer function, which is the GS. If the input is let's say RS and the output is CS, then the GS should be CS by RS. That means, what is the definition of transfer function? We can write that transfer function is the ratio of the output, ratio of the Laplace transform of the output response to the Laplace transform of the input response of a system. It is a system. This whole thing is a system, and this thing is a system. Okay, this thing is a system. The input and the output, the ratio of the output by input is known as the transfer function of the GS. Okay, CS is equal to RS. So CS is equal to what? It's GS into RS. So the CS would be GS into RS. That is the transfer function. Okay, we can write these equations from the transfer function. This is the transfer function. It is very important term in the control system. We'll see one by one. Okay, so here is a example they have given, like find the transfer function represented by dct by dt. This is the equation. From here, how we find the transfer function? This way we can find the transfer function. It is a very simple one. Let me show you. At first, SCS plus 2 CS is equal to RS. What we have done, just convert it to the Laplace transform, taking the Laplace transform both sides. Then take the common, take the CS common. If you take the CS common, then it is S plus 2 is equal to RS. We know what? We know that CS by RS is equal to Laplace transform. So CS by RS, if you do this, then 1 by S plus 2. 1 by S plus 2. That is the your Laplace transform. 1 by S plus 2. Transfer function of this equation. So transfer function of this equation is this one. Okay. If you convert it to the time domain, then you can write, I think, e to the power minus 2t, since it is plus. So instead of s plus 2, you can write e to the power minus 2t. Okay. Okay, then see what they did. So I think I have shown this one. Okay, do you remember this? Just take the partial fraction, then you can do the job. You can do the job. Taking the inverse Laplace transform, you can solve it. See, here is another one. Find the transfer function G is equal to CS by RS corresponding to the differential equation, this one. So finally they find out, just first of all you have to take the Laplace transform of this equation. After taking the Laplace transform, you can solve this like this way. I can show you. No, this is not very important. Let's say this one. Find the differential equation corresponding to the transfer function. The opposite one, they have asked you to the opposite. In that case, you have to do the partial diffraction. Okay, these are the examples. Just check. Okay, find the ramp response for a system whose transfer function is. The transfer function is given here. Here, what you have to do? You have to do some mathematical work. Okay. Partial fraction. In that case, you have to do the partial fraction. Okay, partial fraction is important. Yeah. Now, now come to the electrical network transfer functions. Electrical network transfer functions. Okay, just a minute. I can upload. Okay, 27. I have given to you a sheet last night. Okay, I have given to you a sheet. Can you just write your information there? All of you.
Hello, sir.
Hello, I have given to you a sheet, Excel sheet,
স্যার
right?
স্যার ওটা কি আমাদেরও স্যার পূরণ করতে হবে নাকি স্যার?
না না না, তোমাদের না, জাস্ট ফরেনদের। এখনই লাগবে তো এটা। ওই যে আমাকে বনে থেকে নক দিচ্ছে। Okay, dear foreign students, can you listen
Yes,
to
sir.
me?
Yes,
Uh,
sir. We are hearing.
okay, can you please, in the meantime, when you are listening to me, can you fill up the form?
Sir,
Or
we cannot, sir. The sheet is not properly working, sir.
sheet is not working?
Showing, it's not showing, sir.
Just try to open. It is important because the authority wants it.
No problem, sir. But the sheet is not properly working, sir. In the PDF, sir. Can you change it in the PDF because of that's easier, sir.
Now, if I give you the PDF, then how? Then you have to convert it. It
No
is
problem,
better
sir.
to
But
work on the Excel.
sir, Excel is not working as, sir. For
Excel
me,
is not
I
working,
cannot. Yes, sir. When I'm downloading, it's not working, sir. It's not opening.
not opening.
Yes, sir.
Okay, just a minute. Wait, I'm informing your teacher. I'm downloading it. Now I'm uploading it at another place. Now check. Or you can do one thing. Who is the seer? Seer is present or not? Seer?
It's present, sir.
You present. Okay, do one thing. You can make the similar file in the Word. Okay, make the similar one and do submit it. So if you want, I can short the class because the authority wants it in the morning time. Okay, we can take the class later, but this is urgent.
Mohammed is present. Mohammed is here. Somal is here. So he is present.
See, in the messenger group, I have given to you another form. Can you check? A image. I have given to you image in the messenger. See, you can make a Word file like that and just form. Make a form and fill up. You understand, Sierra? Haldur. Murasi, you are there? Okay, guys, please
Yes, sir.
please fill up the form. Okay, fill up the form or give the information to the CR in the inbox of him. Then he will fill up. Okay, all foreign students. Okay, for your betterment, the university is taking this information, I think. Okay.
Sir.
Okay, can we continue or
Hello,
you
sir.
you need the time? Just
Sir,
in
we
if the giving the information not take than 1 or 2 minutes.
okay, sir. Sir. Hello, sir.
I think within 10 to 15 minutes I'm closing the class. Okay, then you submit. Okay, see, it is the electrical network transfer function, and electrical network transfer function has three things like the resistor, capacitor, and inductor. The resistor R, the capacitor, and inductors. You know the resistor and the capacitor and the inductor. Okay, that is the resistor, capacitor, and that is the inductor. Okay, these three things are important to design a electrical network. So three passive linear components. These are known as passive linear components. Okay, so these three things are important to understand the characteristics of the electrical circuit. Okay. See this figure. See this figure. See this table actually. It is a capacitor, resistor, and inductor. Three things are there. And here is the equation: voltage current equation, and current voltage equation, voltage charge equation, impedance equation, as well as the admittance equations. Three equations are there. You have to use these equations. You have to use these equations in the circuit solution. When do you solve the circuit? When you solve the circuit, then you need these equations. Okay, so this table is very important. See the capacitor equation. Voltage current, voltage is equal to 1 by C, 0 to 1, I tau d tau. Current voltage IT C dVt dt. Voltage charge Vt 1 by C qt. Impedance 1 by Cs. Impedance equation Gs is equal to Vs by Is. Admittance equation Ys is equal to Is by Vs. Okay, these are the equation for these relations for the capacitor, capacitor C, and see the resistor equation V equal to RIT. That is the voltage current equation. And if you look the current voltage, the IT is equal to 1 by R Vt. Voltage charge Vt is R dqt dt. Impedance R. Z is equal to Vs by Is. Admittance Ys is equal to Is by Vs. That is the equation for the resistor. And if you look at the inductor, Vt is equal to L dit dt. It is 1 by L 0 to 1 V tau d tau. It is L d square dt square qt. Impedance Ls. This is 1 by Ls. Okay. So here Vt is the volts, it is the amps, Qt is the coulombs, C is equal to farads, R equal to ohms, G equal to mhos. I think the equation should be like this. L is equal to henries. The symbol should be like this. This is a symbol for mhos. Okay, these are the units. These units and these are the symbols. Simple circuits have mesh analysis. So they have shown you some examples. Let me show you some examples here. Okay, in the figure C, here is the equation circuit diagram. That is the RLC circuit. RLC. That is the RLC circuit. Find the transfer problem is find the transfer function relating the capacitor voltage VCS to input voltage VS in the figure 2.3. And the transfer function relating the capacitor voltage VCS to the input voltage VS in figure 2.3. Okay. So here, at first of all, you have